In this video, we're going to review how to use various set notations to represent lists of numbers and other such things. For the first problem, you're given the natural numbers between 11 and 17. So the first thing I want you to do is to write the set in roster notation. So how would you write that set in roster notation? Take a moment and give it a try. So basically, roster notation, I'm just going to list the numbers between 11 and 17. Now, it's saying between 11 and 17. 11 and 17 are not between themselves. I mean, they're basically the boundaries. So any of the natural numbers between them. So 12, 13, 14, 15, and 16 would be, the list of numbers that are described by that description. You can also use, a shortened version of it using the ellipsis, those three dots there. But this is a rather short set and not really necessary. I mean, but ellipses can be used, in the middle of a list of numbers to kind of basically say, okay, I don't want to write all the ones in between. This is kind of describing, there's numbers in here and you should be able to regenerate them yourself. Now, try to pick the one that is dealing with a set builder notation. So for this one here, it's just, you still use the brackets, and you're going to use this notation x such that x. Well, I'm going to say that x is a natural number, and I mean, these are all natural numbers. I don't really see any restrictions on them. I mean, I see evens and odds. I mean, I don't see anything being skipped, from 12 to 16. So I'm just going to say that x is a natural number, and it's between 11 and 17. With those less than symbols, and notice there's no equal to symbol on them, because again, I cannot be 11 and 17. How do we communicate when we want it to be like a situation where, like this would be 11 and 17 included? Well, let's have a look at the next one. This one here says the natural numbers between 1 and 8 inclusive. So how do you think that's going to change how you write this in roster notation? So try writing this in roster notation and see what you come up with. So in roster notation, I could write the whole thing out. Basically, numbers 1, 2, 3, 4, 5, 6, 7, and 8. Inclusive means when I'm naming those two numbers that I'm also including those two numbers. So, it's 1 and 8 and anything in between them. It's just inclusive is a slightly shorter description that gives us the same thing. Again, since it is a little bit of a longer list, it would make a little bit more sense to, on a situation like this, to maybe write it with the ellipsis again. So that's one way of writing it with an ellipsis. Now try building it in set builder notation. So in set builder notation, not too much different than the previous one. I'm still going to say x is going to be a number that's a natural number. But this time I'm going to define it between 1 and 8, including those. The reason why I'm saying it's a natural number first, I mean, it's going to basically exclude any decimals and fractions and so forth automatically. And so now I'm looking at the counting numbers between 1 and 8, including those two. So now let's try the ones that are some other common number sets that you tend to see a good bit. And how would you relate these? So try this one here. The even natural numbers. So first of all, how would you write this in roster notation? Well, for roster notation, we know what these numbers are. Basically 2, 4, 6, 8, 10, 12, etc., etc. Now I use the ellipsis because this is an infinite set. This would go on forever and ever. I mean, the counting numbers, go on as long as you can go on. So, you're not going to be able to write out the entire set in roster form because, you have to stop sooner or later or you're not going to get anything else done. So how would you write that in set builder notation? In set builder notation, you have to be a little creative with this, because you only want the even natural numbers. You don't want to include any odd numbers in there, but you want to still kind of realize that this is an infinite set, and you want to be able to come up with something that would, generate this set of numbers. So I'm going to say that x is a number such that x equals 2n, where n is a natural number. So if n starts with the natural number 1, 2 times 1 is 2. If n is 2, 2 times 2 is 4, so forth and so on. So that would generate every possible natural number. And oftentimes you do see the representation of 2n, taking the place of even natural numbers and sometimes even integers. So let's try one more. Let's try how would you define the odd natural numbers in a similar fashion? First of all, do it in set notation, in roster notation, I should say. Well, not too much different than the last one. I mean, I know I'm going to need an ellipsis again because this would go on forever and ever. So 1, 3, 5, 7, and an ellipsis. As long as you have enough of the numbers listed to kind of show what the pattern is and make sure that everyone knows, okay, when I start with that one, I'm moving up by 2 each time, and so I can get the pattern of how it's going to continue to change. Now, how would you write this one in set builder notation? Keeping in mind how we did it for the even numbers, how would we do this for the odd numbers to generate the same kind of list? Well, for the odd numbers, very similar, I'm going to use 2n minus 1 because 2n minus 1, if I start with a natural number, 1, that's going to give me the 1. If I put the 2 in, 2 times 2 is 4, minus 1 is 3. As a matter of fact, the 2n minus 1 is a very common way that odd numbers are defined in mathematics, when you're trying to define an entire set. So from time to time in a lot of math courses, you're going to see how we could define common sets of numbers that we use most often using various set notations and formulas and whatnot. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.